All right, so good afternoon to everyone. A very good afternoon to all of you. Hello, Bala. How are you doing, my dear? So, in the last session, guys, what we have done, so in the last session, we have been speaking about the projectile motion. So, tell me if you can see me and hear me properly. Yeah? Okay. So, a warm welcome to all of you guys. So, in the last session, guys, what we have done, so this is the part two of the projectile motion. Okay. So in the last session, guys, we have been dealing with the projectile motion. Okay. So in this session, we are going to continue from that. Okay. So we have dealt with the projectile motion. Acha, thank you, Bala. Okay. So in the last session, projectile motion we have been talking about, and we have been talking about the ground to ground motion. Okay. So have you seen this session? In which I have spoken about the projectile motion, my dear. Because see, this is the session which is the second part of the projectile motion. So anyone who has not seen the projectile motion part one, so this is going to be very difficult for you to understand. Are you getting my point? So have you seen it or haven't you seen it? If you have not seen it, I'll give you a little bit of revision. If you have seen it, then good to go. So all the students who are watching this in the recorded format or not in the live later, if they are watching, I request you to please watch the first part of this video, that is projectile motion. Okay. In that we have spoken about the ground to ground motion. Do you remember that? Yes or no? Because see, now in today's session we are going to see now what is left. So talking about the projectile motion, there is so in the last session we have seen. Acha, you haven't seen mine. Okay. So, but you have some understanding, right? See, when we say, I'll just give you a little brief about it, a little brief, okay? Because see, I want to complete projectile motion as soon as possible because I want to now. I'm getting impatience to move to the Newton's law. Okay, so projectile motion, when I say so ground to ground, so this is nothing but motion under constant gravity. Motion under constant gravity. Okay, so when we deal with this projectile motion, we have to do nothing but use the equation of that requires the constant acceleration. Okay, so what are those equations? V is equal to u plus at. Okay, s is equal to ut plus half a t square, and we had v square is equal to u square plus 2as, right? So these are the equations under which our motion under constant acceleration takes place, right? So when we talk about the projectile motion, see, if you don't know even a thing about the projectile motion, you need not to remember any formula. But if you are remembering the formula, that is good only because you will end up saving some time. But even if you haven't knowing, if you don't know even a single formula of projectile motion, that is also fine. Are you getting my point? Okay, because the projectile motion is nothing but use of these equation under constant gravitational acceleration conditions. So see how we analyze this. So if you see the last session, very simply what we have done, we have analyzed this motion in two parts. One is in x direction and another is y direction. Okay. Now when we evolve, when we analyze these relationships in x and y direction, okay, we get some formulas, right? We get some formulas. Okay, like for example, what formula did we have derived? How, sir? Oh my goodness. I have to repeat the whole thing, it seems. Okay. So how you have read the, you said that you have read the projectile motion, not from me, but from someone you must have, or by yourself you must have. Then so you tell me what is projectile motion? And can you tell me, Bala, like what, see, I request all of you, please watch, whenever you are coming to a part 2 video of something, please watch part 1 of it. Okay, I'll just tell you something. Okay, just let's do it. Let's do it. No worries. Okay. Because I am also today not going to teach you anything new. I am going to, it is like, see, I have given one topic. Yes, yes, yes. I'll provide. Acha, vector notes are also. Oh my goodness. Okay. I'll do it. I'll do it today. Okay. I have all the notes. Okay. Trajectory motion, projectile motion. And just listen to me, Bala. It is not a big deal. I'll just give you. Okay. So just tell me one by one. What I ask you, just tell me that. Are you aware of these equations? Please answer me. Is this equation you are comfortable with these equations, right? Hmm? Yes. Are we comfortable with this equation? I have dealt with one session. I have done one session in which I have dealt with motion under constant gravity. There also we have been using this equation, these equations only. Acha, acha. Okay, that is fine. So are you comfortable in these equations? Right? Let's be more confident. See, physics is all about, yes, 1D kinematics. Okay. Now I'll tell you one thing. So see, I don't know how you are doing, how you are dealing with this equation. I'll give you whenever you are seeing now vertical motion, okay, that is motion under the gravity. Whenever you are seeing the vertical motion from the reference when you are moving in the upward direction, you will go positive. Whenever you are moving in the downward direction, you take negative. This is the sign convention we have to follow. And sign convention that when we talk about the direction, so obviously we are talking about what? Obviously, we are talking about the vectors. So from some reference, any vector which is in upward direction will be taken as positive, and any vector which is in downward direction will be taken as negative. Is that fine to you? Please answer me. Sounds good. So acceleration due to gravity always and always acts downwards. So when we talk about the motion under the gravity, under this sign convention, you take G as always negative, right? Now coming to the projectile motion, see this is the projectile motion which follows some sort of trajectory. Now let's suppose that a body, when a body, ball, stone or anything, it is thrown at a velocity of u in this direction. Let's say it makes an angle of theta from the horizontal. Now, do you guys agree to this point that this is going to follow a path like this and then it is going to strike the ground at some point like this? Okay. So here if I say this is what we call as the basic ground to ground equation. So in the last session we have dealt about it a lot, but like just giving you a revision. Okay, I'll just do a few things here so that we'll get what we are going to do. So here three things are important. One is R. R is the range. One is the height. Okay, what is the maximum height this projectile reach? And the third thing is the time of flight. Okay, so whenever we are talking about the projectile motion, we talk about the three things. One is R, H, and T. So this T is the time of flight. This is the time of flight. Okay, R is the range. Okay, R is the range and H is the maximum height. So see, I hope that you must have memorized all these formulas, huh? Isn't it? Like, see, this is a common case when students, I have seen students are bluntly memorizing all these formulas, like these are the formula of projectile motion, especially the NEET student. But this is not the right approach actually. Okay, I'll tell you how we are going to do it. So if you remember, if you memorize nothing also, it works for you. Just tell me one thing. Just tell me one thing. Basically, this motion happens to be in two dimension because see, when something is moving like this, it is moving in both x and y direction. Do you agree to it? All of you, the live students, please tell me. When something is moving in a trajectory like a projected path, a projection, like sometimes we play balls, you are throwing the ball from one place, your friend is catching from. Yeah, yeah. Don't worry, I'll just tell you. Don't worry, nothing to be worried about. Very simple concept. Very simple. Actually, nothing in. I thought I will complete the projectile motion in 1 hour today. If you would have seen the last session, Nabala, trust me, I would have completed this topic in 1 hour. Okay, because today I can't take more than 1 hour because I have another class to take. Okay, now please understand this. Now this is you. Now you agree that this motion happened to be in x and y direction, right? Now, all you have to do, you have to break down this equation, this motion in x and y direction. And this is what we are going to do today as well. So, x direction, y direction. Okay. Now, tell me, you have seen the vector session with me. Now, this u, this is the velocity, this is the vector. So, if I talk about x direction, what is the initial velocity in x direction? Initial velocity is u cos theta. What is the initial velocity in y direction, sir? Initial velocity in y direction is u sine theta. Now, please tell me, do you agree to this or not? No, don't worry, don't worry. Let's continue with here, and afterwards you can see one, right? You can solve the question. I'll give you the concept here, here this in this session only. I just have a revision because today also we are going to do this only. Nothing new we are going to do. Just tell me this. Yeah, do you agree? That this velocity, since it is an angle of theta from the horizontal, it will have a component in x direction, in the y direction, right? Now, please understand this. In this, if I talk about the acceleration, see, acceleration due to gravity works in the downward direction always. It has nothing to do in the x direction. Acceleration due to gravity do not change or do not, there is no acceleration in the x direction. You are neglecting the air resistance, air friction, all those practical things. Okay, you are just talking about the acceleration due to gravity. So when I say acceleration due to gravity, you very well know it acts in the downward direction. It has nothing to do in x direction. So if I say the acceleration in x direction is 0, would you agree to it? Right? Definitely, sir. Now, acceleration in x direction being 0, what does that mean? So, it means that the velocity in x direction is not going to change throughout this motion, let's suppose from A to B, right? Do you agree? Since there is no acceleration in x direction, this u, the x component of this velocity u, is not going to change throughout the motion. Yeah? Please answer me, all of you. Those who are live can tell me. Okay. So, like if it moves here also, if it goes here also, if it goes here also, everywhere it will have the same horizontal velocity. Same horizontal velocity, isn't it? Please answer me. Yeah, wonderful. So, in x direction, there is no acceleration. Now, please tell me what will be the acceleration in y direction, sir? It is going to be minus g, sir. Why minus g? So, we know that acceleration due to gravity, the acceleration due to gravity is always downward. Okay, it is always downward, and according to our sign convention, we are going to take it as negative. Okay, so I'll take ay is equal to minus g, right? Okay, now if you observe this motion, see what happens. So just try to feel it practically. When you are throwing something, it will reach some maximum height, then it starts falling down. So why it happens? See, this is having a vertical component, that is u sine theta. Now with the motion, see what happens, u remain constant, but this vertical velocity is going to reduce. Why reduce? It is going to reduce because why this vertical velocity is going to reduce with this time? So sir, because acceleration is acting in downward direction. So when acceleration is acting in the downward direction, so see, a ball is flying like this, okay? Now with time, what happens, due to acceleration is in downward direction, this velocity is decreasing. And at some point of time, it becomes 0. Now, if I talk about the C point specifically, at C point, the horizontal velocity will be there, but the vertical velocity will become 0, Vy will become 0. That is why from this point onward, it will start falling down. Why it will start falling down? Because acceleration is in negative direction. Now, after beyond this point, what is going to happen? The velocity will be in downward direction. It will keep on increasing. And from the law of conservation of energy, ultimately it is going to reach to this same velocity u sine theta and u cos theta. Now, do you agree to all these points or not? Please answer me that. Bala. See, don't worry, we are going to do the same thing today also. See, what is left? No new concept. Okay, so like in books, it is written like, no, the projectile motion from a height, projectile motion from an inclined plane down to top to down, all is nothing, we are going to do the same thing. Not an iota of thing we are going to do differently. Like this only. Right? Please answer me. This is clear up to this point. Now let's use these very equation. Now I wanted to have the time of flight. This is the first thing I wanted to have now. Time of flight. Let's try to sort it out. So time of flight. So if I take the motion in the y direction, beta, if I take the motion in the y direction, so if I take the motion in the y direction, what is going to happen? So I wanted to have the time. So can I say S is equal to ut plus half a t square? Do you agree to it or not? Please answer me. Bole. Huh? Let's do it with the help of, do you want to do it with the help of a question or something? Right? Please answer me. Right? Okay? Okay? Ut is equal to half at square. Right? Now when ut is equal to half at square, now I am using the motion. Let's say we are seeing from directly from A to B. Directly from A to B. So I am applying the motion in the y direction. Shall I write Sy Uy Ay? Right? Because we are seeing the motion in the y direction. Now can you tell me what is the displacement in y direction from A to B? What is the displacement in y direction from A to B? Can you tell me that, beta? What is the displacement in y direction from A to B? So obviously, sir, it is 0 now. See, this is point A, this flowed like this, and it reaches this B point. So it has no displacement in the y direction, right? If you write, if let's suppose this is your axis, this is your axis, this is your origin. Now from origin, if you see, so it will have some x1 coordinate in 0 and y coordinate will be x2 in 0. Now do you agree to this, that it has no displacement in the y direction? Displacement is the shortest distance between 2 points. So what is the, when I say in the y direction, what is the distance between A and B? So this is basically 0. Do you agree or not? Please answer me with that. Yes? Yes? Right. So Sy is 0. Now what is Uy? So sir, we understand that Uy. What is Uy, sir? What is Uy? It is U sine theta. Okay, and t is the time of flight. That is, what is the time it takes from A to B? So it is capital T plus half. What is Ay? It is minus G, and this is capital T square. Did I do anything new? I just used the equations of motion, isn't it? Equation of motion in one dimension under constant acceleration. Okay, now from here, can I write T? See, I have taken T as common. It will become U sine theta minus g by 2 of t is equal to 0. So t will become 0, beta. T will become 0 and t will become 2u sine theta upon g. Okay. So this is your time of flight. So we are getting 0 also. So basically 0 is when the motion is started and 2u sine theta by g is the time when it reaches the B point. Do you agree to it or not? Time of flight is calculated. I assume that till now you have been memorizing this formula, although I also recommend that you memorize this because this is an important topic. But if at all you forget the formula, and how many formula you will be able to, if we now come to inclined plane, you have to memorize one more formula. Okay. So what we can do, we can just by the concepts also we can do the question. Are you getting my point? Okay. Now talking about the what else we have to find? We have to find H. Okay, so this is one formula. We have to find H now. Okay, we have to find the H now. So now if I consider the motion between A to, let's suppose this point is C. Now again I am considering the motion from A to C and I am considering the motion in Y direction. Now from A to C, if I say, and I am considering the Y direction, see, do you see that velocity at C? Velocity at C, that is final velocity. So I am considering from A to C now. At C, the velocity at y is equal to 0. Do you agree or not? Please answer me. Right? Of course, sir. That is why at C point, it momentarily come to an halt. It momentarily stop. That is why you reach the maximum height, and afterwards it start, you know, having a motion that it is falling towards the ground. Right? So at C point, beta, the velocity in y direction becomes 0. And what is the initial velocity in y direction, sir? This is u sine theta. Acceleration we have, that is what? Minus of g, and we wanted to find the height, that is h. So if I see, if I have, see what is going to happen. So if I apply the motion between A to C, can we say V square is equal to U square plus 2AS U square, V square is equal to U square plus 2AS? Can we say so? Okay. Now I am applying in the y direction. So Vy is equal to 0, U square is equal to U sine theta whole of square plus 2, that is minus g, and this is the maximum height, that is h, right? That is the maximum height, that is h. So from here h will become u square sine square theta upon 2g. Do you agree or not, beta? Please answer me. Yeah, please tell me. This is what you memorize as the maximum height formula. Yes or no? Hmm? You can memorize now also, but knowing the concept will help you solving and understanding the question, and if anything if asked otherwise, you will be able to deal with it. Understood? Now similarly, you can find the horizontal range. Similarly, we can find the horizontal range. So if I find the horizontal range, I need to see the motion in the x direction. I need to see the motion in the x direction. Now again considering the motion in the x direction from A to B. From A to B. So motion in the x direction from A to B is C. If I apply, so I want to find the range. Okay. Now what is the information I am having? So if I am seeing in the x direction, ux is equal to u cos theta. What is the acceleration in x direction? So this is going to be 0. Time we already have. Time we already have calculated 2u sine theta upon g. 2u sine theta upon g. Isn't it? Right? Or did we or didn't we? Right? Okay. Or otherwise we have the h. Okay. So u square. So this is fine only, na? So we have the t also. T is the time we already have, that is 2u sine theta by g. Yeah, super easy, na? Very easy it is. Now, what we wanted the range. So, range is the displacement between A and B. So, range is this, na? So, from A, when you are considering from A to B, do you agree that this R is nothing but your horizontal range? This R is nothing but your horizontal displacement. Now, if I apply the equation of motion, that is xx is equal to ut plus half a t square. So, what is going to be sx? This is going to be r. U cos theta. What is this t? So, this is t, we know 2u sine theta upon g, and a is 0 in the x direction. Okay. So, this will become 0. Now this r will become 2u square, or I'll write u square 2 sine theta cos theta upon g, isn't it? U square 2 sine theta cos theta upon g, right? Now from there you can do r is equal to u square sine 2 theta upon g. Is that fine? This is again one formula that you normally memorize. Now, when I started the lecture, I said that projectile motion is nothing but, use of these equations. That is, it is nothing but the case of motion under constant gravity. The only thing is that you are applying these motions in x and y direction. Now, is it clear to you or not? Please answer me. Okay, please answer me, madam. So you go to the first part of this question and you would see we have solved a lot of questions over here on this, right? So you just do those questions and definitely you will be more comfortable. Now these formulas, are you comfortable? Like now how we do it, nothing new. It is, just like the same thing. Okay, now let's start the today's session. So this all was completed in the last session, but we have given it a good enough revision. Now let's start to derive or to see the equation of trajectory. Equation of trajectory. Okay. Now what does that mean? First of all, let's try to understand this. Now this some body is thrown from the point A, let's suppose like this. And if it is thrown like this, it probably have followed a path like this. It probably have followed a path like this. Okay. It probably have followed a path somewhat like this. Okay. Now let's try to understand this. So now this path, is it a path which follows? So it could be a circular path, it could be a line. So actually this is parabola. This is a parabolic curve. Sir, how we come to know that this is the parabolic curve? Now please understand it. So for understanding any type of motion, okay, for understanding any type of motion, so basically see, okay, Bala, no worries. So see, if it is parabolic or not, if it is circular or not, if it is, a straight line or not. So whatever kind of motion is there, you have to relate y and x. If you have to relate y with x, okay. So how you come to know that this is parabolic curve or not? So for that, what you have to do? So you have to apply some mathematics, and yeah, open downward. That is okay. Okay, that is okay. Parabolic curve it is, but how and why we shall believe it? Okay. So if it is a parabolic curve, please understand this that we must have something like this. Y square is proportional to x, or x square or y is proportional to x square. Okay, this is what we call as a parabolic equation. So when we develop the in this sort of a motion, when I develop or when we develop a relationship between y and x, it must be a relationship having a square, right? Then only we must believe na, that this is a parabolic function. Okay, are you getting my point? So see, knowing the motion, whether it is parabolic or not, we need to develop an equation. Okay, an equation, and that is what we call as the equation of trajectory. Are you getting my point? There are two forms of this equation of trajectory. Let's derive it. So what are we going to do? So how we are going to derive? So we are going to do nothing, the same thing we are going to do. Are you getting my point? See, in the whole of the projectile motion, whether it is projectile from a height, whether it is projectile in an incline from down to top or from top to down, everywhere you have to use the same concept, same equation, same thing. Understood? Nothing new in any of it. Let's derive it. Let's derive it. So again, what we have to do, sir. So what one thing that we have to do to derive this? So I want to develop the relationship between displacement in y and displacement in the x. So anyway, I have to eliminate what? So we must derive and try to eliminate t. We must eliminate what? We must eliminate this t. Okay. If we are able to eliminate this t, then only we'll be able to derive the problem properly. So let's move. Okay. So sir, we know again we have to go the same way, same direction, x direction. So what is the motion in x direction? So let's take a point. Let's take a point. So let's suppose this is your point. Okay, I'll have taken the point, and the coordinate of it is x and y. Okay, x and y. Now what is this x with us? So this x is this distance, right? And what is this y? So y is obviously this distance, isn't it? Y is obviously this distance, right? This is x and this is y. Now, if I let's call this point as C. Okay, so if I consider the motion between A to C, and let's apply the equation of motion in x and y direction separately. So in x direction, what is the initial velocity, so it is u cos theta. Okay, there is no acceleration in x direction, we know. Okay, so if I write this, and let's suppose to reach this point, see the time taken is t. So time taken will be, common for both x and y direction. Now let's apply here. So can I write that? So we know S is equal to ut, and what equation I'm going to apply? S is equal to ut plus half a t square. Now when I apply in the x direction, I can very easily, comfortably can write. So what is the displacement in x direction? So it is plus x. Okay, why it is plus x? So you see a is the difference, and x point is in the positive x direction. So I'll take it as plus x. So x is equal to ut plus half at square. So ux plus half ax t square, right? So can I write this as, so it is x, ux is what? U cos theta, and this is t, u cos theta, this is t. Any issue till this point? Please tell me. No, sir, absolutely not. Now let's apply the same thing in the y direction. So if I do the same thing in the y direction, we'll have the displacement in y direction equal to plus y, because from the reference it is upwards, right? So it is going to plus y. What is uy, sir? It is u sine theta. And what is ay, sir? It is always minus g. Now let's apply the same equation. So it will become y, and uy is u sine theta. So I'll just write. Am I teaching very fast? Huh? Just let me know if I'm teaching very fast. Na? If I start teaching too much of pace, because sometimes I skip writing the thing. See, this is a bad habit of mine. Sometimes I say this equation and directly put the data, don't write the equation. So if anything you feel like that, please feel free to tell me. I'll improve. Okay. So y is equal to uy t plus half ay t square. So what is going to be the sy? This is y. Uy is u sine theta, t, and this is going to be minus g by 2 t square, right? Do you agree? Do you agree? No worries, sir. No worries. Okay. Now, if I take, now see, this is y u sine theta t minus gt square. So what we have to do, sir? We want to have, we want to develop relationship between, okay? We want to develop the relationship between, you can develop the relationship between what, beta? So we can develop the relationship between x and y. So what we need to do, we need to eliminate this t. So can we write t is equal to x upon u cos theta? T is equal to x upon u cos theta. So when t is equal to x upon u cos theta, let's place it in this equation. So we have y is equal to u sine theta, y is equal to u sine theta of t minus g by 2 of t square. So if I place the value of t in this equation, so it will become y is equal to u sine theta, x upon u cos theta. Okay, I'll just place the value of t here, minus g by 2 t square. So it is x by cos theta whole of a square. Is it fine, beta? Please answer me. Right? Did I do anything new? So just putting the values here and there. Right? Right. So can I write? Can I write from here? So see, y will become, see, u and u will be cancelled out. Sin theta cos theta will become tan theta. Sin theta cos theta will become tan theta of x. Okay. Minus, see, so this is going to be 1 by 2 g cos square theta, 1 by 2 g cos square theta x square. Is it fine? Would you please answer me? And sorry, it is x by u cos theta. I skipped u here. Just a moment. I'll have to write u also. So it is u. So we'll have a u square here. Okay. Okay. Yes or no? Please answer me. So this is what we call as the equation of trajectory. Okay. This is nothing but the equation of trajectory. Okay. This is one form of it. I'll just show you another form. This is what we call as the equation of what? This is the equation of trajectory. Okay. And now from this equation, we can very clearly observe that y is proportional to x square. Y is proportional to x square. That is, this is the proof that the projectile motion follows a parabolic path or a parabolic curve during its flight. Understood, beta? Please answer me. Okay. Like in any physics thing, if it is coming out to be proportional to y, proportional to x, it's coming out. So that means it follows the linear relation. If it is coming out, y square is equal to x, that means it follows, the equation of the circle. Understood? Okay. Very good, she's saying. No, no, no worries, no worries. The last class, I wasn't expecting you also because see, you were there in all the vector classes, so there is no point of you to attend the one-shot complete division of the vectors, right? But this is not an, this is, see, I tell you, projectile motion is nothing but the use of the motion under the constant gravity. Do we need to remember this equation? There is no need here. You can see, only thing if you have to see that putting in projectile motion, you have to do x and y direction. By the way, very good, Shiza. Okay, keep doing so. Right? Keep completing the chapter. See, wherever you find. This is the right thing. Okay, okay, because see there are so many things that is happening, so you are a very good student, you definitely can attain a good rank, so you complete whatever you can, so we will do in our pace. Okay, but you also keep completing the chapters, keep completing the things, right? Okay. Okay, so what kind of a questions can be asked? So see, in your books in NCRT, this equation is given, no? Equation of trajectory, so how this is derived? श्रद्धा बेटा, आपका अगर प्रोजेक्टाइल का कॉन्सेप्ट क्लियर नहीं है तो आप एक ही चीज कर सकते हैं, उसको पढ़ सकते हैं। इसके अलावा आप क्या कर सकते हैं बताइए? तो पढ़ें कैसे बेटा? देखिए अब मैं नहीं, मतलब अब इस सेशन में तो मैं इस चीज को रिवाइज नहीं करूँगा, रिवाइज नहीं करा सकता। देखिए समझिए, अभी ये इस सेशन का पार्ट 2 है। ठीक है, तो ये जितनी चीजें मैंने पिछले पार्ट में पढ़ाया था बेटा, ये मैंने अभी अभी फिर से रिपीट किया है। ठीक है, तो दिस सेक्शन विल गो वेस्ट अदरवाइज, है ना? आई होप यू अंडरस्टैंड दिस। सी, बट आप पूछ रहे हैं, देखो सिंपल बात बताता हूँ श्रद्धा बेटा आपको मैं। देखो प्रोजेक्टाइल मोशन को आप लोग कोई, सबको मैं कह रहा हूँ, ओके, प्रोजेक्टाइल मोशन कोई नया टॉपिक नहीं है, ये कोई टॉपिक ही नहीं है। दिस इज नो टॉपिक, दिस इज जस्ट एन एप्लीकेशन ऑफ मोशन अंडर कांस्टेंट ग्रेविटी, as the way if you are solving, just treat it like a problem of motion under constant gravity only in x and y direction। ठीक है, तो हम केवल इन्हीं इक्वेशन का, हाँ वेरी गुड शीज राइट, तो हम बेटा बस कुछ नहीं करना होता है, इन्हीं इक्वेशन का यूज करना होता है एक्स और वाई डायरेक्शन में। हाँ, तो बस मैं एक बार आपसे मतलब ये रिक्वेस्ट करूंगा कि आप इस सेशन को रिप्ले भले मत करिए, आप इसका प्रोजेक्टाइल मोशन का पार्ट 1 देख लीजिए, आपका पूरा कॉन्सेप्ट क्लियर हो जाएगा प्रोजेक्टाइल मोशन का। ठीक है, आज बेटा मैंने सोचा था ना कि 1 घंटे के अंदर मैं ये पूरा चैप्टर निपटा दूंगा, क्योंकि बचा ही कुछ नहीं ना। अब देखो ये इक्वेशन ऑफ, मतलब आपकी एनसीईआरटी इसी लाइन में पढ़ाती है ना, ग्राउंड टू ग्राउंड प्रोजेक्टाइल। ठीक है, और उसके बाद जो है इक्वेशन ऑफ द ट्रेजेक्ट्री, फिर प्रोजेक्टाइल फ्रॉम अ हाइट, उसके फॉर्मूले याद करा देंगे आपको लोग। ठीक है, फिर इंक्लाइन प्लेन वाले फॉर्मूले याद करने को बोल देंगे, वो रेंज का इतना लंबा चौड़ा राक्षस जैसा फॉर्मूला है। ठीक है, या ठीक है, राक्षस जैसे वो फॉर्मूला, उसको थोड़ी ना याद करना है। आर यू गेटिंग माई पॉइंट? वी आर गोइंग टू डू बाई दिस थिंग्स ओनली। आई एम जस्ट showing you that how you can apply the same concept. Okay, so you can stay in the session, you will learn something. That is what we are going to do. Okay, now please understand this. ठीक है, so this is one way. So what kind of a question we can expect? So I'll just give you a simple one. So y is equal to ax minus bx square. Okay. Okay. So now if this is the equation, I ask you to find. So So let's suppose it is given like this. This is the in place of A and B there can be some value. Huh? Our channel is hidden. Acha, Bala. Please share it to your friends also then if you are liking it. Right. So this is the equation of projectile. So find initial velocity. So this is a new channel also. No? This we started a month back on the Unacademy platform, and see this is a channel of Unacademy actually. I'm just an educator of Unacademy and doing my duty. That's all. So this is H and R. Okay, let's try. Let's try this. कैसे करेंगे? How you got to do this? Very simple, no? Very simple. Voice is not clear. Acha. My voice is it my voice is fine or not? I'll just check the settings. Is my voice clear or not? Can you guys hear me properly? आप लोग मुझे ठीक से सुन पा रहे हो ना? Please answer me. अच्छा. Shraddha, better there might be some, internet glitch at your end because like the other students are suggesting that this is fine only. You can just refresh the page and see if it's working for you. So how we are going to do this question, sir? So we see simply by seeing the equation, you can judge that this is something has to do with this equation. So we just have derived the equation. So in the if you remember it in the examination, well and good. Otherwise, quickly apply x and y direction uh, motion equation, and you can get this equation very comfortably. So now simply see we do have to compare. So this is the standard. Okay, now it is clear. Okay, wonderful. So Shraddha, also this is English channel. I hope like it doesn't bother your learning. Okay. So G by 2 u square cos square theta x square. Okay. X square. So now from here we are getting A is equal to tan theta. A is equal to tan theta. See, just compare these two equations. So A is equal to tan theta, right? So from here you will get theta, obviously. Now you have, so now comparing these two equations. So B is G upon 2 u square cos square theta. So theta you will get from here, that is tan inverse A. Now once you have the theta, G is already there, so you will be able to find the u. Okay, I just made this question. I hope like if the values are given instead of A and B, you will be able to compare. So what we are doing very simply, Shraddha, are you getting my point, beta? So x के कंपोनेंट को कंपेयर कर लिया. x में ऊपर a है नीचे tan थीटा है तो tan थीटा और a को कंपेयर कर लिया. What we did? ax minus bx square. So component of x compared with the standard equation of trajectory. Okay, so a will become tan theta. Okay, Now from this you will be able to get the theta, and when you make the comparison of the coefficient of x square, you will be able to get u. Once u and theta is found, is there any issue in finding th and r? Sir, definitely there is no issue. See, I'll leave the calculation to you guys. To 2u sine theta by g, right? This way you can, so once you have u, once you have theta, if anybody is stopping you to finding the t, please tell me if anybody is stopping you finding the t. Yeah, please tell me. If anybody is stopping you finding the h, once you have theta u square sine square theta upon 2g, right? Is anybody stopping you to finding the r? No, sir, absolutely not. Once we have u, once we have theta, definitely we are going to find all this thing. Agreed? Please answer me, Vida. Please answer me. Clear? Clear to everyone? Sir, we have seen this equation in some other form also, na? Have we or haven't we? Yes, sir. Your formula will be too long. Formula, why we'll be using the formula, she said? See, when you have a value of A and when you have a value of B, I just made a random question. Instead of A, it might be root 3. Now, if it is written root 3, you will get the value of theta. Acha, acha, acha. You haven't write on the chat box. That is okay. But I hope you got this concept. Okay. Now, have you seen one more form of this equation of trajectory? So one form is this now. I'll just show you one more thing. So y is equal to x tan theta minus g by 2 u square cos square theta. So from where this equation is derived? Yeah, from where this equation is derived? So this equation is derived from the standard equations of motion used in the constant gravitational acceleration condition, right? So y is equal to x tan theta minus g x square upon 2 u square cos square theta, right? Now there is one more form of this, okay? Sometimes it is given in terms of the range also. Okay, now can we do one thing? Can we do one thing? See, I'll just make another form of it. So y is equal to x tan theta, okay, minus. So see, I want to get some, yeah, exactly. I want to convert this formula in the form of the range. So let's do one thing. Let's write it like this. G2 u square cos square theta, u square cos square theta, and this is x square. Now, if in this equation I'll multiply a sine theta here, I multiply a sine theta here. So will it change the equation? No, sir, not at all. You have multiplied the same thing and divided the same thing. So the equation remain unchanged, isn't it? The equation remains unchanged, obviously. Right, now equation remain unchanged. So what is going to happen next? So sir, can we do like this? Y is equal to x tan theta. Okay, y is equal to x tan theta. Now see, it will become, now see, let's do some mathematics here. See, in the, like, I came up live also yesterday and given you some tips regarding the preparation. Now see, you have to be good at some basic mathematics now. Sine theta, cos theta, tan theta, all this. Now see, this is u square. Let me write it here. Now see, 2 cos square theta. So may I write it 2 cos theta, and let's take this sine theta with the cos theta. It will become sine 2 theta. Sir, how you did it? See, 2 cos square theta. Let one cos theta go with the sine theta. So it will become tan theta. Do you agree or not? Please answer me. Okay. So 2 cos square theta sine theta. I'll keep 2 cos theta and sine theta. 2 cos theta sine theta. So 2 cos theta sine theta will become sine 2 theta. Will become sine 2 theta. Right. And sine theta by cos theta will become tan theta. Did you get this or not? Please answer me. Did you get this or not? Please answer me. Yeah. Now from this equation, if I take this x tan theta is common, Bala and Shraddha, please tell me, beta. So x tan theta, it will become 1 minus, so it is going to be now u square 2 theta u square sine 2 theta by g. This is r square, no? This is r. This is r. So u square sine 2 theta upon g. So from the numerator, I can take the g in the denominator, isn't it? From this numerator, I can take this g to the denominator. So it will become u square sine 2 theta by g, that will become r, and x theta we have taken as common. So it will become like this. So this is going to be another equation in the terms of range for the motion of projectile. So this is also known as the equation of trajectory. So whenever if you search on Google the equation of trajectory for projectile motion, you will get these two equations. Are you getting my point? So these are not two equations, but the same equation we derived from the equations of motion and did some little bit mathematics to it, and we get this. Is it fine? Would you please answer me? Yeah, understood. All of you. All of you. Hmm? Please answer me. Right? Wonderful. So these are the two equation of trajectory. Now see, let's suppose. So what is the use? So I'll give you one use of it. See, let's suppose the motion happened to be from here to here. Okay, from here to here. This is a ground to ground projectile. Okay, ground to ground projectile, and let's suppose there is a point x and y. There is some point x and y. Now, if I join this by a straight line here, if I join this by the straight line here, and if I join this by a straight line here, let's suppose this angle is alpha, this angle is, let's suppose, beta, and see this body or this ball is thrown at a velocity of u from this angle theta. Now from this equation, with the help of this equation, you can prove that tan theta is equal to tan alpha plus tan beta. This is one standard expression that you see. So this is coming from nowhere, but it is coming from this equation only. This is coming from this equation only. Are you getting my point, beta? Are you getting my point? Okay. Okay. Please answer me. Right? Please answer me. Okay. So no need of proving it. You can prove it by using simple geometry. See, this is y, this is x, right? This is y, this is x. So you can use this relation. You can use this relation. See, if you want to prove it also, see left hand side. If I talk about the left hand side, so left hand side will become tan theta. Tan theta is what? From this equation we can write this is y by x. This is y by x, and this is, see, if I take the LCM, it will become r minus x, so it will become r upon r minus x, isn't it? See, from the equation of this trajectory, tan theta will become y by x, and this is r minus x upon r, so r will go in the numerator, r minus x will come in the denominator, isn't it? Now if you see the right hand side of this relation, right hand side, what is this? Tan alpha. So tan alpha is y by x, it is equal to y by x, isn't it? Okay, and sorry, my bad. Okay, so what is this tan beta? So if this is x, this is r minus x, isn't it? This is r minus x, that is the range. Okay, r minus x. So now tan beta, it is going to be y upon r minus x, y upon r minus x. You add both of it, you are getting the same thing, aren't you? Right? So if we add both of it, so y by x plus y upon r minus x, right? So what will become the LCM? What is going to become the LCM? See if you add, so I just lack the space here. So when you add both of it, what is the LCM? R minus x into x, isn't it? This is going to be r minus x into x. This is going to be the LCM, and this is going to be r minus x into y. Okay, or I'll take y as common. It will become r minus x, and this is going to become x plus x. So see, it will become x will be cancelled out. So same thing are we getting or not? R upon r minus x, y by x. So LHS is equal to right hand side. That means this has been proven. Okay, so you may have it in your mind. That's if tan theta. So if 2 points like initial position to the find, sometimes it helps you to find the coordinate of any position. Okay, yeah, Shrita, please ask me. Please ask me, but please ask me quickly because I have another session to take. Okay, I thought I would complete the whole projectile motion uh, today itself, but okay, got it yourself. Wonderful. Right, so this is the equation of trajectory. So I'll keep it to this point in this session. Okay, what kind of a question can be asked from here? I'll just give you one. See, it is said, yeah, yeah. It is said, let's make one question quickly. So let's suppose a projectile, a ball is thrown like this, okay, like this, and after 4 meters covering horizontal distance, it reach a vertical point that is 4 meter. Okay, that is 4 meter. That is this 4 meter, and the range is, and afterwards this is 14 meter. Let's suppose. So now you are supposed to find this theta. Sometimes they make a question like this. See, they can give you the question like this. See, they can say like there is a tank. Okay, from tank, you know, क्या बोलते हैं उसको? A bomb is, you know, uh, projected, and it hit the target which is 4 meter ahead of it. Okay, a person is standing and it hits that target. Are you getting my point? After 4 meter. Now in this case, what is going to be at what angle this bullet must be fired? So they can make anything like this. So you may get trouble from where we have to do, right? So you can apply this concept. Can you give me the theta here? What is going to be the theta? What is going to be the theta? And you also, if you want to find what is going to be the theta in this case. Yeah, very good. She's saying. So, sir, very simply we can do. Very simply we can do. So, see, this funda projectile motion. So, this one is important. This is useful, more useful than this one. Okay, so see, if you have, so where to use this equation? So, where you use this concept? So, whenever you are having a coordinate of a point, when you have a coordinate of a point and you are asked about this range, time, height, initial velocity, anything like that, okay, then you can use this equation. So how we are going to use this equation? So this is going to be theta. So this is 4. So we know y is equal to x tan theta, x tan theta 1 minus x by r. Okay, so what is this y? So we'll take the coordinate here. So this is 4. What is x? This is 4. This is tan theta. This is going to be 1 minus 4. What is the range? So range is from initial to the final point distance. So this is 18. This is 18, right? So from here you can get the theta, obviously. Now range is given. We know the formula of range. What is the range? So it is u square. It is u square sine 2 theta upon g. So u square sine 2 theta upon g. So you have the theta now. So you can find the u. Is it clear to you guys? Will you be able to do this kind of a question? Please answer me. Will it? Right? So this is the use of the motion of the equation of the trajectory. Bala. Shisa, you have understood this? Yeah? Bala, what about you, beta? Shraddha, if you are there in the session. Yeah, wonderful. So you understood it in what kind of a question you got to use this kind of equation and where to use this equation. Yes, agreed. Wonderful. So I'll have to keep it to this point in the session. So in the next session, I'll complete the projectile motion. But for that, please come after revising motion under constant gravity and projectile motion. Okay? Yeah. When range is given. Range is given na 18. Otherwise, they will give you some other data. Okay? So see, my point is that projectile motion is nothing new. So if you want to see this also, see, just do this thing in your mind. We'll complete it in the next session. So now let's suppose we are throwing. So this is given in your book now. So if we are throwing something like this, okay, from a tower, from some height, this is also a kind of projectile motion. So what we are going to do, we are going to do the same thing, right? So if something is thrown from an inclined plane, like from here it goes like this. In this, what we are going to do, we are going to do the same thing. What is the difference here? So we have the incline. So remember, in the vectors, I told you one topic that you can always convert x and y, isn't it? We can find the components of any vector along. Acha. Yeah, yeah, definitely, definitely. That is why we are here, Nambala. So in this, what we have to do, the only difference in projectile, so with formulas, everyone is, memorizing the formulas of different cases of projectile motion. There is no need of it. In this case, what we got to do, there will be some acceleration in x, there will be some acceleration in y. We will be using the equation of motion only. We'll get develop some equation, solve 2, 3 problems. It is over. Okay, that is what is going to happen. Okay, but we'll do all this thing in the next session. So that will be all in this session. So please do subscribe the channel, please like the video, please share amongst your friend, and I hope you have enjoyed the session today. Okay, I couldn't do what is. No, no, why won't I teach it? There is nothing to teach also, she said. This is already completed. If I say this is already completed, that is also not a wrong statement. Are you getting my point? In this, see, you try doing yourself, all of you. Okay, just only thing you have to do in this case, see what you have to do in this case. Again, see from here to here. See, this is going to be the displacement. This, let's suppose this is given 20 meter. This is point A, this is point B. So you consider the motion. No, no, Bala. There's nothing like that here. A lot of people teach a lot of things. So from A and B, if you see in the y direction, you consider the y direction, that is 20. What is the initial velocity in y direction? It is 0 in this case. Okay. And what is the acceleration? It is minus g. Right. You have the displacement, you will get the time. So same things we are going to do, nothing else. In this case, see, g is like this now. In this case, see, g is like this, right? So this g is going to have a component in this direction, that is g sine theta, and it is going to have a component here, that is g cos theta. Okay, that is g cos theta. Now we will be considering the motion in this x and y. Understood? Will do nothing but will use the same equations of constant acceleration, motion under constant gravity. Yeah, in this case, ax is not equal to 0 because it is inclined now. So when it is something is moving in an inclined way, that means that g will act in both the direction. That is the only difference. There is no other difference. Here you will develop a long formula of range and something like that. So never memorize all these things, right? If you want to memorize, you can only memorize the ground to ground case formulas. Otherwise, there is no need. Understood? You will take it as a question of motion under constant gravity. It will give you less burden in your mind, right? Unnecessary memorizing of formulas will, take some space in your mind. You will keep revising it, right? So many things will happen. Okay. So although I'll keep it to this point in this session, thank you very much. Do subscribe and we'll see you in the next session. Have a good day.